let's go through your answers and see if you have any questions. All right. How is a sample related to a population? Remember, the sample is a subset, part of the population. So you go for your number first, whatever they say, how many participants, how many people in the study, how many people responded, and you say, are there more? That's how you know if it's the sample or the population. You with me, guys? Okay. What is the difference between a parameter and a statistic? Technically, looking at it, there isn't. But a parameter is something said about a population. A statistic said about a sample. But to look at it, you would never know the difference. In fact, we call everything a statistic. Because the statistic, it's kind of like a dual definition. It is the collection, the reporting, the analyzing of everything. So go through and tell me if you have any questions. We good so far? Unless you have a problem, no sense going over everything because you probably have it. Number 21. This is nice. This is a Venn diagram. The box of the Venn diagram contains everything. The population. Good. The inside is the sample, the part of it. So these are parties of registered voters in Warren County, and these are part that voted, who responded to the online survey. These are all the registered voters. These are who responded. So there's your sample out of your population. Okay? And the Venn diagram really lends itself nice to this. This is probably hard to see. Ages of adults in the United States who own cell phones. And these are the ages who own a Samsung cell phone, a particular cell phone. So you've got all the people and then the Samsung people. Okay? Okay, again, go for the number and see if you can say, are there more? Are there more than 1,015 adults in the United States? Yes. So this is a sample. And it comes from all U.S. adults, the collection of all possible adults. 1,015 took part in this survey. This right here, 32%, is your statistic. That's the statistic. That doesn't...
Just to throw you off?
No, because what did they report on? They have to tell you something that they reported on. So now, either this is going to be a parameter or it's going to be a statistic. Yes, because it deals with your sample. So once you figure out who your sample is, who your population is, you find out, what did I want to know about this? That's my information. Okay? That's my statistic. That's called your descriptive statistics. And as we talked about yesterday, you can then make an inference from that. You can look at it and infer something yourself, or hopefully your study that this is a little extra about it, your study has everything else in it about that. A survey of 12,082 U.S. adults. Are there more than that in the United States?
Okay.
Yes, so that's a sample. And this, therefore, is your statistic. Okay? A survey of 55 law firms, and we know there's more than that, so all the law firms, and then the 55 that told us what their hourly billing rate was. A survey of 202 pilots. Are there more pilots than that? That's your sample from all pilots. Collection of the effects on all pilots. Again, if the information they give you is about a sample, it's a statistic. And this one told you of the 65 of the 500. 500 is your population. 65 is your sample.
You have to rate all that price for 500 population.
That's fine. Yeah, that's fine. I just tend to write it out in case anybody has any, questions. And I tend to show a lot more stuff up here. This way you can kind of figure out where these are easy. They're just definitions. The average salary for 35 of the company's 1,200, since this is the sample, that's a statistic. 62 of the 97 passengers aboard survived. Why is that a parameter? Why is that the population?
Because there's not 92 of all the passengers that were on the
Yes, this is all the passengers aboard. This is your parameter. That's the piece of information they gave you. Like your statistic about this. You had 62 survived.
35 is a statistic because it's not all of the country.
Right, it's part. It's part.
How about the rest of it?
Well, this because of the way they wrote it. What did they tell you about the 97 passengers? What did they tell you? They have 97 passengers up on the Hindenburg. Okay, what did they tell you about this 97? 62 survivors. This is the information they're giving you. This is the statistic they're coming up with based on this. And these are all the passengers aboard the Hindenburg. These are all the passengers aboard the Hindenburg. 97 is not a part of them. It's a population of all the people on board. It probably would have been a little easier if they said 2/3 survived. Right? A 62 out of 97 is almost like 2/3, right? So if they would have said 2/3 or 60% survived, would you see that as the statistic, the information? Yeah, but they just listed it as a number. Any statistics, things that are countable, collectible.
Why is it 35?
35 says the annual salary for 35 of a company's 1,200. So they only took 35 people out of 1,200 accountants. So this is your sample that they found. They only sampled 35 and found their average.
They don't survive.
No, they didn't take 62 of the 97. This is your statistic. See this statistic right here? Let's call this a statistic. Let me rewrite this. Of the 97 passengers on the Hindenburg, 60% survived. Okay, let's write it like this. It's tricky. So, of the 97, are there more than 97? No, 97 is our population. What did they tell us? What information did they tell us? 60% survived. Now, I'm taking this out. Because this is a population, this is called the parameter. 62 survived. That's where that 62 came from. Okay? You got to watch the wording. The wording on some of these get a little tricky. Okay? Yeah, it's somebody else's book. Okay, so we're talking qualitative versus quantitative. And that's how we separate our two pieces of data. Quantitative parts, we're going to break that down into a couple of different ways. And qualitative, we can order them. We can just look at your name, your number, colors, your eye color, your gender. Qualitative. Nothing to compare, nothing to measure. It's a label. It's an attribute. So we have two types of data. This quantitative has the word quantitative. So that's an easy way to remember that. All right. So in this example, where they list the models and the suggested retail price, which column is qualitative? The model. This is qualitative. There's no measurements. And then this one would be what? Quantitative. I can say this one is $3,000 less than this one. This one's $3,000 more than that one. I can say it's 1.5 times as much, half as much, a quarter of as much. Okay? If I can make any math statement at all on it, it's quantitative. If I can't make a max statement, it's qualitative. All right, take a look at this chart. What part is the qualitative? The cities. Good. Qualitative. It's just a label. A label of a city. And this guy, quantitative. Okay. All right, so we've got qualitative versus quantitative. Now, under these, we break them down. This is the trickier part. We have 4 levels of data. This is in your notes as well. Nominal, and these are how I remember them as well. Nominal almost looks like the word name in there. It's just a name. It's a number, an attribute, a label. It's strictly qualitative, just like the cities, the name of the car. Qualitative, nominal. So anything that has no calculations, no type of order, your number on your jersey. Aaron's number 5. What number are you at? 7. Is Oliver getting to be the 7th position on his team and Aaron the 5th position on his team? Do they sit on the bench number 5, number 7? Is he better than Aaron because he's 7 and he's 5? No, it's just a label. A label. There's no way to categorize that label. Zip codes. It just gives you a grouping, a label. Phone numbers. Anything that has no type of order is nominal. Ordinal almost looks like the word order. This can be either. This can be either qualitative or quantitative. Ordinal you see a lot because ordinal will tell you list these, your favorite one first. So you list all your songs. I give you 5 songs and I say list your favorite one first. List them in order what you like to listen to. 1 through 5. Even though it's the name of a song, you're giving some kind of order to it. So then we consider it ordinal data. Even though it's just the name of a song. The cars. Remember we did the one with the cars? All the cars? If we listed them like the smallest car to the largest car, even though the car is a nominal name, we're giving some kind of order to it. We always go for the highest level of data here. So the highest level would be ordinal. Any rankings. Sometimes you see a survey and it will say, and I hate these, and it says least likely, most likely, somewhat likely. So those are ordinal. It's kind of ordering this. They're really tough ones to get because if I somewhat like this, how is that different from least likely? How is that different from most likely? You don't know what people consider the most likely, least likely, somewhat likely. You know when you have to rate something and they give you those little surveys to take? Those are really tough ones, the extent that you like them on a basis of 1 to 10. Why is my 9 different than Leslie's 9? Pain management. You know, you go to the hospital, the first thing they say is, what's your pain level? Well, this is the worst thing that's ever happened to me. It's a 10. And I might have just had like, you know, a little slice on my finger that I needed a couple of stitches for. Really, that's not a major thing as compared to if my leg broke and my bone was sticking out. But to me, if that's the worst thing that's ever happened to me, it's a 10. So you got to be careful when you have people rate things because their levels might be different than yours. And we see this on a lot of surveys. Interval. Interval is the toughest one. Interval data is always quantitative. We can have order to this. We can order this. And we can have meaningful differences, such as the temperature. Yeah. Well, such as the temperature. We could say this is 3 degrees colder. If today is 72 and yesterday was 75, we could say today is 3 degrees cooler than yesterday. Yesterday was 3 degrees warmer than today. But we cannot say it's twice as hot as yesterday. We can't make any comparisons like that. We can get some kind of difference in here. And what's key to this is what we call an inherent zero. An inherent zero says you have nothing. I have no dollars. I have no books on my desk. A zero in temperature says it is a temperature. So in an interval, this has meaning, because then you're negative 5 degrees, you're negative 10 degrees. That is an actual value, 0 degrees. In a ratio, a zero means I have none. No books, no pencils, nothing. So that's a difference here. If your zero has meaning, you're probably in an interval. Time and temperature are two very, very good examples. However, time, if they say this took me 62 minutes, and it took you 31 minutes, can I now say I'm twice as slow? That you did it in half the time? It took me twice as long? So if your time is in minutes, then you're going to be ratio, the next level. If your time says it's 2:45 and this was at 4:45, I can only say this is 2 hours later. I can't say this is twice as late. See the difference?
So is that meaningful?
This is meaningful, but I can't make a ratio. Ratio is your highest level. If I use minutes, that still is time, but I'm adding your total minutes up. This would have to be a time stamp, in other words. I can't say this took me twice as long. I have no calculation for that. But this I can do it if it's in minutes. Ratio is the highest level. If you can say half as much, twice as much, 1.5 times as much, if you can make any kind of ratio, divide or multiply, then you've got ratio data. This is your highest level. This is the highest level you get. Now, I'm going to flip to this chart for a second at the very end. What happens is, each time you go up, you can do the one before that. So we always have to shoot for the highest level we can. Nominal says, I'm just a name. Just a name. I can make a category for this. This is a Honda. This is a Ford. I can't put it in order. Can't do anything else. Ordinal, here's my order. That's the highest. Therefore, I can put a name on this. Interval says, here's my meaningful difference. I can subtract or add them together. But I'm also responsible for the ones before it. And ratio says, this is the highest. This is the only one that you can make a multiple of the other one. Take half as much, take twice as much. And yes, it has all the ones before it. Okay, these are the tricky ones. Okay? So let's take a look at a couple examples. Okay, here's two data sets. The first one says the top 5 grossing movies of 2012, and it lists them. What level of measurement is this? Ordinal. Why?
Because it's an order.
It's in order. Yeah, they listed in order. The top 5. Is this quantitative or qualitative? Well, this is a label for the movie, but quantitative because we do have some kind of order in it. Remember, that can be either one, either way. How about this one?
That's nominal.
Nominal, absolutely. This is nominal because these are just names of types of movies. Action, adventure, comedy. Just names. There's no order to this. So that's just nominal. Okay? All right, try these. The final standings for the Pacific Division of the National Basketball Association. Monty, what do you think?
Is it ordinal?
Okay, why?
Standings from first to last.
From first to last. So here are your standings from top to bottom. It's got order in it. So ordinal. Very good. This is ordinal. Okay. Daniel, what would you say the last one? Collection of phone numbers.
Interval?
So, okay, interval. Here's a phone number.
Oh, no. No, you can't calculate anything, right?
Can't calculate any differences here. Nominal. Very good. So when we're not sure, write some out. And as soon as we wrote out the numbers, Daniel said you can't calculate anything off of that. And is there a special order to this? Is this number, smaller than that number? No. No order to this. So that's nominal. Good. That's how I want you to keep thinking. Okay, these two data sets. We've got the New York Yankees World Series victories by year, the year that they won. What would you say that is? Okay, it's got some kind of order, but is that the highest level we can go? Interval. So why wouldn't you say interval?
Because that's just showing select time.
Time, and can we say that 1927 is 4 years after 1923? Right. So ordinal because it has an order to it, but then the highest level would be interval. So our answer here is interval. It's always the highest level. So keep asking yourself, do I have a meaningful difference between the years? Can I say, oh, then 9 years later they also won? Right? I have some kind of meaningful difference. How about the 2012 American League home run totals? These are how many home runs they made. What would the highest level be? Oliver? Okay, so would it be nominal, ratio, interval, or no?
Ordinal?
Well, I could put them in order. So
Ratio.
can I say one has half as much as the other, twice as much as the other? Not necessarily with these numbers, but you can. If you made a ratio 165 to 211, you could make a ratio, right?
There's a whole different one.
But be careful. I'm looking at the home run totals. This is what they want me to look at.
Nominal.
Interval?
Ratio.
Oh.
I can make a ratio. Is what I'm saying. We can make a ratio. We can almost say that this guy is 3/4 as much as that one. It doesn't have to be exactly half, but you'll be able to make a ratio. I got twice as many home runs as the other team does. Always start at the lowest one and keep asking, do I have a higher one? Do I have a higher one? Do I have a higher one? Are we just about to end?
Yeah.
3 minutes? Okay, hang on.